Okay, so we'll start our discussion on cattails with their geography. So, where they tend to grow, their most native habitat, and where they tend to prosper and proliferate the best. So, cattails have flat blade like leaves and grow to heights of 3 to 10 feet. So, they prefer wetland areas. As a wetland species, they're most common in large marshes and on the edge of ponds. The two most common species in the United States are the T. latifolia, or the broad-leafed cattail, and the T. angustifolia, the narrow-leafed cattail. As wetland plants, they primarily prefer shallow flooded conditions, so the edges of ponds and marshes, swamps, often in waters that are about 1 to 1.5 feet in depth. They can exist in some cases floating above deeper waters, but they're more common on the edges of ponds. One of the things about cattails is that once they've established themselves on a pond's edge, they tend to grow very rapidly and grow around the pond. So pond owners tend to see them as a hassle to get rid of and something that causes problems in their recreational pond. So cattails are very, very successful in wetland, marsh edge of pond areas. Next, we'll talk about the history of cattails and how they've been used throughout time by different groups of people and what they can be used for. So, to start off, the Western Apache used cattails for food, where the Havasupai and the Kawaisu used cattails for thatching their roofs and walls. So those are two very different groups of uses that you could do with cattails. One is for eating and one is for more labor intensive purposes. So on that line, the Northern Paiute use cattails for construction, clothing, and boats, which is again a wide variety of different uses. The Pima used cattails for being weaved into mats and baskets. And there's a lot of other uses. For example, the Pawnee Dakota and the Kawaisu use the down from cattail flowers for their bedding. The Navajo use the leaves on the cattails for storage and medicine baskets, and bed mats and coiled mats. So again, back to the more clothing and weaving aspect of cattails. The Apache use the cattail pollen as a general curative agent, so a medicinal use comes into play here. And the Cahuilla, the Omaha, and the Pawnee use the topical ointments they got from cattails for burns and bleeding wounds. They also use the down from flowering stalk for chafing powder. So you can see that there's a lot of things that you could do with the different parts of a cattail plant. So in summary then, cattails are a wetland plant and they can be used for a variety of different things. Next, Lania will talk about the more scientific aspects of the cattail.
Now we're going to talk about the scientific name of cattails. Cattails are placed in the family Typhaceae, with all of the species having a common genus, Typha. Typha includes a group of different cattails, and there are 10 different species of Typha, but the most widespread species is Typha latifolia. Typha latifolia has a two-part name. The first part, tuft, comes from bulrush or cattail, and latifolia comes from the Latin word meaning broadleaf, which refers to the leaves of this distinctive species, and that sets it apart from the other species. Because cattails are wet plants and grow in aqueous environments, they have to have a specific morphology and specific structure. So their height ranges from 1 to 3 meters, with some species having shorter height. They have a distinctive cigar-like head that contains the seed, and also the head lies on a cellulose-rich rhizome, which is the stem of the cattail, and it holds the plant upright and also plays a part in growing the plant and spreading the plant in other environments. The root usually grows up to from 12 to 16 leaves. The leaves are basal, erect, linear, and have a D-shaped cross section. The head usually is 2 to 20 centimeters in size. The origin of cattails. Cattails have been growing around for a long time, and they have originated from Eurasia and North America. The common breed that is spread these days is hybrid cattail, which is a mixture between two different species, Typha angustifolia and Typha latifolia, which is native to Europe but also has been considered a distinct species in North America. Cattails spread through seeds and now inhabit most places around the world in that way. Cattails usually grow in any freshwater, slow-moving environment and aqueous environments, but they can inhabit wetlands over a broad spectrum of climates such as tropical, subtropical, southern, northern temperates, as well as humid coastal and dry continental climates. Having this broad spectrum of different habitats makes it easy for them to grow in almost any area or any space around the world, and that's favorable. For them to be grown in a place, they can grow easily and rapidly once they are planted in water in a warm place, and they are usually grown in a fast pace when the environment is favorable or the conditions are favorable. For them to grow, it is important to have a rhizome or the part of a rhizome when planting. Use of fertilizers is required when growing commercially dependable products, and it's usually either used in a form of liquid fertilizers or as a form of water plant food, and either way is used. And once every 3 years, the rhizomes of the plant need to be removed and the plant cut into sections and planted again, because they have the lifespan and they could grow or exhaust the soil after that period. Even though cattails have a lot of benefits and a lot of uses, they have some downside as well and impacts on the environment and ecology. For example, cattails are very reproductive and they can dominate plant communities and reduce the biodiversity of that environment by allowing only themselves to grow. Also, cattails are usually grown in lakes or ponds and on the sides, and so they can hinder fishing, swimming, and boating and other activities of the population, and that can be problematic. And because they form dense fields quickly, they can impede water flow through the irrigation or drainage channels and preventing farming activities in that area, and they can interfere with fish harvests and aquaculture facilities and preventing food for the people that live in that area. And also, it all comes back to cattails being very productive plants, growing through a large field densely and quickly, and that's because they cannot be controlled, and sometimes a lot of farmers have to use pesticides or other ways to control the population, but that could be very difficult at times, and it could harm the soil and the nutrients in that environment and not let farmers grow any other species. And that brings us to the end of the ecology section of the presentation.
So the first thing I want to talk about is just some of the biological adaptations that allow cattails to survive in wetlands, because as we'll see a little bit later on, their ability to survive in these environments is one of the main benefits they have as a biorenewable resource. So cattails can range from 3 feet to 10 feet in height, and this just allows them to survive in areas where the water levels would fluctuate, which is very common in wetland areas, and it depends on things like rainfall and that. But so this height just allows them to never be completely submerged in water, which is necessary for their survival. They also have these long, hollow stems that are composed of these tough internal fibers that allow them to resist high winds, and that's also why their leaves tend to be narrow and pointed, is just to resist some of the wind that they're going to experience in wetland areas. So the root system of cattails, which are also known as rhizomes, stay submerged in water, and they have these pores in them that that allow them to absorb some solids and some organic bacteria and various chemicals like ammonia and phosphates and other things you would find in oxygen-deficient environments. And so they can absorb these, and that makes them useful in using them as secondary sewage, so just getting solids, removing solids and some organics from wastewater, and also for bioremediation for areas that have become oxygen deficient, because they can take up these excess chemicals, then you can remove them and plant what you need to go there, and there's been a lot of success with that. So the cattail rhizomes are about 40 to 60% starch by weight, and these rhizomes are mostly amylose, but they contain a small amount of amylopectin, and so amylose and amylopectin are just two different polymer units of starch, which is just a polymer of glucose. So amylose is when you have two glucose molecules joined together by a hemiacetal bond between the C1 and the C4 carbon of two glucose molecules, and amylopectin is when you get a hemiacetal bond between the C1 and the C6 carbons of two glucose monomers. And so this starch is mostly amylose. And to obtain ethanol from this starch, you go through a 4-step process. The first step is gelatinization, which is basically grinding up these rhizomes into like a meal and suspending them in a liquid and creating like a slurry. Liquefaction, where you add the enzyme amylase, which targets the C1, C4 hemiacetal bonds in amylose, and it breaks them up, and so you end up with just various dextrins and maltose and smaller glucose polymer units. And then to complete the saccharification process, you add some more enzymes and just break down all of these various polymer units into just glucose monomers. And then you add yeast and wait for it to ferment, and you end up with 2 molecules of ethanol per 1 molecule of glucose. So it's a bit of an intensive process, but you do get a fairly good payoff in the end of it. And as far as yields go for cattails, you can get about 400 to a little over 1,000 gallons per acre, with some studies even saying you could get up to 2,000 gallons per acre if we improve our extraction techniques. As far as that compares to corn, which is the largest source of ethanol in the U.S., in terms of yield, corn is pretty much on the same level as the lower side of cattail rhizomes, where you can get about 420 gallons per acre. And the starch that you get from corn is a little bit different in structure. It's mostly amylopectin and less amylose than cattail rhizomes are, but it's still starch. So they're processed pretty much the same way. So really the main benefit of using cattails over corn is that they can be grown in wetland areas, which are areas that are not really easy to exploit for biorenewable resources generally. And that also, if we improve our extraction techniques, we could be getting a much, much higher yield than we can with corn. So not only can we use them as biofuels, but we can also take the cattail leaves and extract fibers from them. And these fibers can be used in paper making and in construction. And so these fibers are similar to bundles of cellulose. They just are, you can see in the picture, they form these matrices like this, and they form these fibers, and they are lignocellulosic in nature, which just means they contain both cellulose and lignin. But something interesting about these cattail fibers is that depending on how you extract them from the leaves, you can get a wide range of diameters and different mechanical properties, which just allows a lot of control for what you want these fibers to be used for. It allows you to get a lot of different uses out of them. But as far as building materials go and paper making goes, the best results were obtained when a moderate alkali treatment was used to extract the fibers. So cattail leaves are used to make a building material called typha board, which has we get about 5 times the yield of typha board than we do from conifer forests for the same amount of building material. That's one main advantage, is just a higher yield from cattail leaves. And so another main advantage is that these leaves have an open cell spongy structure, which gives them really good insulating and static properties, but then you still have these long cattail fibers that are in the leaves, so you don't have to sacrifice any strength. So you get not only superior insulating and static properties compared to other construction materials, but you also are not sacrificing strength. The last use for these cattail fibers is to grind them into a pulp and add them to short fibered paper. And basically what's happening is just the long fibers of the cattails increase the surface area over which interfiber bonding can take place. And so you just increase your amount of interfiber bonding, and you get an increase in burst strength and tensile strength and some other mechanical properties.
Okay. So let's talk about the future of cattails in industry. There are a few possible areas in which cattails can serve as a raw material, namely paper making, biofuel production, and wastewater treatment. So let's start with paper making. Typha fibers are much larger than wood fibers, and because of this, they have a much higher tensile strength and modulus of elasticity, or stiffness. Here's a sheet of cattail paper where you can clearly see the large fibers. Cattails are not as available as wood, so it wouldn't make sense to go straight to pure cattail paper. However, because of their low lignin content, which is around 6%, they would make great additives to a kraft pulp system. And because of their high tensile strength, mixing the Typha with the kraft pulp in a 40-60 ratio can double the tensile strength and modulus of elasticity of the sheet. This would be great for high quality paper, such as large posters, that need the extra strength to hold up for longer periods of time. Next, we have biofuel production. The root system of the Typha plant is very high in starch content, which can serve as a great starting material for ethanol. They have about 40% starch versus the 70% starch found in corn. And something very beneficial about Typha is that they make use of wetland areas where corn and other biofuel crops cannot survive in. However, because of this wetland environment, there are several drawbacks to using Typha as a biofuel crop. First, they require about twice the amount of water to grow to maturity than corn does. And second, because of the large amount of water surrounding the plants, the moisture content of the root system is about 90%. So by weight, you're not really getting as much starch as you think you are. Also, they are hard to harvest. It's hard for heavy machinery to get into these wetland areas and harvest the root system. However, there have been some cases where modified potato harvesters have worked well, and some other machinery. However, it is still difficult for this large equipment to get in there and harvest the root systems. And then finally, wastewater treatment. Wetlands have the ability to draw high amounts of compounds from the water. The root systems can draw nutrients directly from the water, and because of this, wastewater treatment plants have used constructed wetlands to help to purify the waste effluent. And then by harvesting the Typha after they have absorbed these compounds, the high levels can then be removed from the water system. This is a very inexpensive way for wastewater treatment plants to help lower these high levels of compounds. However, this wouldn't be considered a primary wastewater treatment option. There would have to be some other more vigorous chemical treatment prior to a constructed wetland solution.
Now that we've looked at the ecology, biochemistry, and geography of cattails, it becomes important to address the economic aspect of this plant. More specifically, today I will be discussing the commercial and individual growth of the plant, its sale and usage, and also the beneficial attributes it possesses. While it may be fact that cattails are grown commercially, the specifics of how much is grown and where are hard to measure exactly, as the plant grows mostly in wetlands. The growth of the plant is also considered weed-like, so commercial regulation is not usually applied. Because of this, it is often grown commercially, not bought or sold. The cattails that are grown for commercial use, however, are generally used in fields of bioenergy and also environmental preservation. Moreover, individual use of the plant, individual growth and use of the plant is also common, as its versatility provides various benefits to the individual. This image represents the commercial harvesting of cattails. It both demonstrates the process in which it is harvested and also the areas in which the plant is grown. As noted by the caption, it is mostly grown in wetlands, while there are also many other instances in which it is harvested next to highways where the plant tends to flourish, as I'm sure most of us have seen. As was previously mentioned, there is hardly a market for the sale of cattails, but this does not mean that it is not widely used. On a commercial scale, cattails are harvested for use as a feedstock in a variety of bioenergy technologies. The harvest of cattails provides vast economic benefits as it provides a safe alternative to most modern fuels as it can be used as ethanol. Furthermore, it also plays an important role in environmental preservation. Some examples include improvement of water quality and also improved nutrient cycling as the harvesting process releases captured phosphorus. In addition to this, the cattail plant can also be grown on an individual scale due to its incredible versatility. This versatility stems from the plant's natural ability to be grown and harvested very easily. Moreover, the plants can also be substituted into more than 8 different kinds of food due to the fact that it contains starch and gluten-based flour, allowing it to be used as a substitute for bread and other foods. Furthermore, it also has strong medicinal qualities as its ash can be used as an antiseptic or a styptic for cuts, wounds, bruises, burns, scratches, etc. Lastly, it has many other uses in the structural sense. This means that it can be used to build shelter or even clothes. As can be seen here, it can be used to build shelter, make baskets, or even used as an arrow shaft in hunting. Essentially, these individual applications are only limited by the user's creativity, and its applications greatly outweigh the commercial and individual cost. This leads us to wonder why it isn't used more widely, and why it doesn't play a larger role in the modern economy.
Okay, and just to elaborate a little bit on the outlook, some general uses not necessarily pertaining to any particular industry. When you look at the cattail plant, there are the different parts of the plant. So there is the seed pod versus the green part of the plant, so the leaves, the stems. For the seeds, there are several uses, specifically looking at the fiber aspect of it, kind of the fluffy part that you think of when you think of a cattail. That top part, you can see on the right on the slides how fluffy it is, which lends itself really good for furniture cushions. Throughout much of history has been used for stuffing things, as well as aviation jackets and life preservers. The Navy and Air Force have used them in the past, and that fabric can actually be used to make the thread that is used to make baseballs as well. Other uses for the seeds would be there's an oil that you can get from them, kind of like linseed oil, so quick drying, a wax product, and then other than a byproduct from producing the oil and wax with the pods would be a meal, which is used as cattle feed. The leaves and stems, fibers from them can be used as well in furniture. Burlap sacks, often they're treated chemically to soften beforehand. Without that, just simply the leaves, if you dry them, they can be used for weaving. Many Native American tribes use them for that. They can be made into rope, utilizing that fiber, much like something like hemp, for example. And on the upper right is a picture of some cattail rope. There's also a jelly-like substance in the leaves that can be used for applications in possibly adhesives and facial creams or shaving creams, stuff like that. As well, it also has nutritional value, so the lower stalks can be eaten along with the roots, and I guess are quite nutritious. So one application specifically with production, a product that is made is called Typha board. It is a insulation material and is being looked at to be applied specifically with buildings, all using Typha board. It combines a unique combination of insulation and strength. It has a high resistance to mold growth, protection from fire, noise control, and thermal energy costs. It lowers energy consumption in production. It has a low energy consumption in production, and it is directly compostable. It appears to be similar to like a compressed wood board, as you see on the right, some sort of particle board, although instead of the wood particles and chips, etc., it would be made specifically of the cattail greenery, the plant material. Currently is being used in existing buildings. There's an expo that happens every year that they have a team of engineers and specifically with this Typha board product to make only Typha board structures. So it is being looked at as a complete building source. So like it would replace lumber. Typha board renders ventilation systems unnecessary. It has a low energy consumption during the entire product life cycle, which is super important, as we talked about earlier in this class. It is renewable, cattails. You can grow them over and over and over. And it is harvested annually versus every 20 years or more, such as lumber. Therefore, you can get a lot higher yield of cattails per hectare or like per area than you can for lumber. Another application would be biofuels, touched briefly earlier in this our presentation. The starch from the plant is found in the rhizomes, so kind of the lower part of the plant and the root area. It contains 40 to 60% starch, whereas corn contains about 70. And it is estimated using various methodologies that cattails could produce 1,000 to 2,500 gallons per acre of ethanol. That's opposed to 448 gallons per acre of corn. So that goes back to you can grow a lot more per area and harvest it more often and grow it quicker. And in North Carolina, researchers at the Agricultural and Technical State University are currently doing research converting cattails into ethanol as a way to bring down the price of fossil fuels and add that to the ethanol market. So does have a very real application and currently is being experimented with. Another application with biofuels would be for fuel pellets. You would take the greenery byproducts or just solely use it for that purpose. And it would be similar to pellets that are currently made using waste from like lumber mills, the sawdust. And is aimed at reducing coal use because you're using it for heating. And it's already being done in Latvia, Estonia, and Finland. So what are the environmental impacts of using cattails as a feedstock? It would create a reduced dependence on non-renewable fuel sources such as coal and petroleum. They are grown in water and marshy areas, and these areas are often otherwise unused. So therefore, that would open up more land for food supplies, as opposed to when you grow corn right now for ethanol, you are competing with land that could be used for the food industry, which is also a huge problem. So using cattails as a feedstock opens up that land so it can be used for food, helping out that problem as well. Cattails are a great bioremediator, and they do improve the water quality. They're a ginormous natural filter, and they provide habitat for countless species. That includes nesting and cover for various birds and waterfowl, food for muskrats, spawning sites for fish, countless ways in which they are contributing to the biodiversity of our environment. The economical impacts, hopefully it would increase the amount of ethanol available if that became a well-recognized source of fuel, which would bring down the cost of gasoline and again reduce petroleum usage. Theoretically, we could also increase the amount of fuel pellets available, which would decrease coal dependence in areas where wood byproducts such as these wood pellets are not readily available, and consequently a decreased price in coal would occur because they would want to sell more of it, so it would still be a competitor in the market, but it is an option. Social impacts of using cattails as a feedstock. Like was talked earlier in the Outlook section, it is applicable in the pulp and paper industry, the construction industry, fuel, waste management. So that all those industries, it would be creating or reshaping countless jobs. Some examples: Fraunhofer, one of the research partners for the TIFA Board Expo, currently has 103 job openings. So with that one company alone, 103 people are being affected. The average paper mill has 68 workers. So any place that you would implement cattails into your paper making, all of those people's jobs would be impacted as the process would slightly change. And the record production of 15.3 billion gallons of ethanol supported 74,420 direct jobs in renewable fuel production and agriculture, as well as 264,756 indirect and induced jobs across all sectors of the economy. And that's looking at specifically for corn ethanol production. However, if you implement cattail ethanol into that spectrum, that group of product, all of those jobs are automatically affected in some way by the slight shift in production. Here are some of our sources. And kind of to wrap up, as you can see, cattails can be used so many ways, are very applicable. They can be grown in many, many places and in land that we don't necessarily use for anything else across the country, across the world, globally. They can be grown. They've been used throughout history, and I hope that we look into using them more in the future. Thank you.